In this video, we're going to talk about micrometers, and specifically we're going to look at the Vernier Micrometer. That's an analog style like this that is made for taking external dimensions. You'll find lots of different micrometers in the automotive shop, and depending on the level of work that's being done there, it's very common for us to have external micrometers like this one that help us measure brake rotors and brake disc dimensions, as well as a lot of internal engine work when we're looking at clearances for oil, crankshaft, to journals and bearings or cylinder bores. In all those cases, these are really precise measurements. And so this specific type of micrometer is a Vernier micrometer. The Vernier element tells us that it can measure down to 1/10,000th of an inch. And so how thick is a 10,000th? It's pretty hard to imagine that. And so the best example I've got is to take a sheet of paper like this. We'll talk about how to get this set up and measure. But first, if we put the piece of paper between what we call the anvils, run my spindle down. I'm going to make sure it's not too tight. I can drag my paper out, which is a good sign. And then I look at that measurement. It's about 4/1000ths of an inch, so 0.004. And how do I put that into perspective? Well, in the inside of an engine, it might be common for us to have an oil clearance specification or specification between components that's only 5/10,000ths of an inch. Well, if I've got 4/1000ths on my sheet of paper and I'm thinking about a 5/10,000th specification, well, that sheet of paper, in order to really think about my tolerance, I've got to take this sheet of paper and cut it into 8 slices. And so just imagine how absurd that sounds to cut this into 8 slices. That's the level of precision that this Vernier micrometer is supposed to go to. And so in getting set up for this tool, it's important to make sure it's clean. And so using a degreaser or something that is tool safe to clean all the surfaces between these two anvils, that's an important step in using this. The other big challenge is that I've got to always exert the proper amount of tension, engaging the part right between these 2 points. I've also got to make sure that I'm straight on something that is got 2 parallel sides, something like this hydraulic lifter. It can be difficult sometimes to get that measurement correct. And so this is why, like in the case of brake rotors, you'll often find a micrometer like this one, that it's an external mic, it's purpose-built for brake rotors, and one of the anvils is a sharp point so that it's easier to get that engaged on a brake rotor nice and straight so you get an accurate read. Back to our micrometer, we're going to use this 0 to 1 inch external Vernier micrometer. It is analog, so that means I've got to interpret these numbers. It works a lot like a tape measure, and in some ways, knowing the inside of this is going to help us understand what's going on. And so I've got my threaded section here that moves the spindle so I can put the spindle against the anvil. The screw inside this is set up with 40 threads per inch. And so this helps me with how the tool works. It helps me set it up into quarters, right? And so on the body of the tool down here, this, because it is a 0 to 1 inch, if I go all the way down and touch these two together, I've got 0 inches. And so to start, this is how I can confirm the accuracy of my tool. So if I run it down a couple times like this, I can use my ratchet. I'm just throwing it until it stops. This one is set up well. I've got exactly 0 when I run this down. If that was not 0, there's a little spanner wrench here where I can take this and actually move it, and I move this line so that as my spindle has rotated and stopped, hit the anvil, I will ensure that these line up properly. You can imagine with precision, this is an important step to get this thing set up. If I was on a larger micrometer and I can't get the spindle and anvil to touch, then I should have something called a standard or a gauge rod that I could run out, and it is a very specific value, and so I could go out and set that like there. So if I had anything larger than a 1 inch, I've got to use that gauge rod. So we'll go ahead and set up for measuring my lifter here. One of the things in terms of getting the proper tension set, using my ratchet is important. One of the ways that I can kind of experiment with this process is to get a feeler gauge like this one. So this is a 20 thousandths feeler gauge, and I could take this and set it in my micrometer. The nice thing about this experiment is that I know what the outcome should be. I know I need to get to 20 thousandths, and when I get it there, I can now kind of move this feeler gauge back and forth, and I have a feeling for what is the tension that I need to achieve to ensure that everything is flat and being properly measured. Because if I leave it loose, that reading is going to be large. If I over-engage it and over-torque it, I could actually flex the tool. I'm bending the tool, and again, I'm going to get an incorrect reading. So there I've got my 20, just a little bit of drag as I move that back and forth. Good experiment to do. It gets us acquainted with the tool. So we go back to our lifter here. We got to run out so that we can get around the outside of this. We're just going to measure the bore. So there I've used my ratchet. I can move my component through and feel there's a little bit of drag. I'm always using my ratchet so that I don't overexert. The other step that I'm going to do is that as I engage the part, I'm going to repeat it a few times with the ratchet. And when I do that, I'm going to look at where do I fall on my measurement just in the thousandths place. So here, just over 17. And again, just over 17. So if I can achieve the same general number, being within a close distance to that 1,000ths mark, and I can do that 3 times with my ratchet, that should be a good sign that I've got a consistent and accurate reading. So now with that achieved, I can turn this lock. That locks my spindle so it won't move. And now we can move on to interpreting what these numbers are. So now we'll move into another camera. We'll get a really close look at how to read this and interpret these numbers. And so I begin first with my numbers down here at my base. These 0, 1, 2, 3, 4, these are 1/10 of an inch. So I begin at the left side and essentially move to my right. So first I'm going to pay attention to what is my micrometer in terms of whole inches. This is 0 to 1. So I do not need any whole inches, but for the sake of consistency, we'll just go ahead and put a 0.00 up on the screen so that we can add all these numbers together. And I find it to be a great process, especially early on, to write these numbers down so that we don't miss a set as we go through adding and create an error. So by 0, and then I move on. Now I can look over here, and this is where I've got 1/10 of an inch markings. So these larger ones at the very bottom, these represent a 1/10 of an inch. So I run out, I look for the largest one, but the other thing I have to understand is that between every 1/10, I've got 3 marks. And as I pass those marks, this is rotating. And the scale of my sleeve out here is that I count up to 25 and then I go on and start over. So if you imagine I've got 1/10 of an inch here, 3 lines, those represent 0, 25 thousandths, 50 thousandths, 75 thousandths, 100, 125, 150, 175, 200, on and on. And so those numbers are always going to build, and that's going to help me determine which ones I need to pay attention to here in this initial set. So I've definitely passed my 8. You can see I've passed the 8 plus another line. So for my 1/10 spot, I can put 0.8000 and record that. Next, I'm going to look toward my lines. I could put these together, but maybe early on I keep them separate. But there I've got 1/4 tenth. And remember, that 1/4 tenth is my process to count up to a 1/10. So 0.025 or 25 thousandths is what I get having passed that line. Next, I'm going to look at the sleeve out here. Right there, it's just past my 17. That 17 represents thousandths. Again, we're using this to count up from 0 to 25 thousandths on and on to get it to 100 thousandths. So here I've got 17. So now I can record 0.017 or 17 thousandths. The last spot on this, I've got to take the micrometer and turn it. And now I've got to look at these numbers here. This is my Vernier scale. And the way that this one works is that I've got to hold it straight to my eye and just kind of rotate it and look for the one line here that lines up closest with a line up there on the sleeve. I'm not concerned with which one it is at the moment. I just need to find the one that's closest. We were pretty close to 17, so I should expect it to be a fairly low number because again, these numbers are also counting. This is my 10,000 spot where I'm building between each of the thousandths up here. So we look at this straight on, rotate a little bit, looks to be like probably the 210,000, or number 2 here, is the closest. That's my last number, so I write that up. That is 2 10,000ths, or 0.0002. So I come back and I add them up. I've got my 0.8, I've got my 0.025, I've got my 0.017, and at the end, I've got my 2 10,000ths. So my final reading comes out to be 0.8422, and that's the reading I've got for that hydraulic lifter. And that's the process to use an external vernier micrometer like this one, hopefully to achieve some consistent and accurate results. And to get there, it's going to take a little bit of practice, some note keeping, right? A sheet of paper is going to help us keep track of our measurements, and keeping things clean and consistent, right? That's going to lead to good outcomes. So repeating the measurement several times, making sure we have some accuracy is really critical early on. And then once you get going a little bit faster with things, you're comfortable, and then you can really do something like a crankshaft where you expect several of those journals to be the same. You can do them quite quick because ultimately you end up only looking at maybe the last 2 digits or last 2 readings of your micrometer because we expect them to be pretty close, right? And so unless there's been a major issue on that crankshaft, they're going to be within a couple thousandths of each other from manufacturing. Thanks for watching. Get out there, measure some things, take some practice, take your time, ask for help when you need it.